Now it's about DC circuits. Here we are going to discuss simple concepts like Ohm's law and resistors in series and parallel, in a sense current division and voltage division rule, and some KVL problems. One example in KVL and energy and power. So DC circuits, here the first thing is about the Ohm's law. So what is Ohm's law? Ohm's law, in a sense, the voltage is directly proportional to the current I by keeping the resistance value as constant at constant temperature. So the Ohm's law, sometimes they may ask a definition, define with some limitations of Ohm's law. So at constant temperature, the current flowing through the conductor is directly proportional to the voltage or potential difference across the two ends of the conductor. Or simply, voltage is directly proportional to the current I and resistance is constant. V equal to IR is a formula. And what is the limitation? It is applicable only for the linear elements such as resistor. We can't apply Ohm's law for capacitors or for diodes or for transistors and all. We can apply only for the linear elements, that is resistor. It is not applicable for the non-linear elements. It is not applicable for the non-linear like diodes, voltage regulators and so and so. And it is applicable only with a constant temperature. And it does not hold good for the non-metallic conductors. So we can write definition with the limitations of Ohm's law. And resistance in series and resistance in parallel. So in resistance in series, if the resistance are connected in series, or if n number of resistance are connected in series, then how to find the total resistance of the circuit. So here we are considering two resistance R1 and R2, both are connected in series, and we know that if elements are connected in series, then current flows through that elements are same and the voltage drop across the elements are different. So I is the current from the supply, V is the total voltage and I is the current from that supply, and V1 is a voltage drop across R1 and V2 is a voltage drop across R2. And if we write a KVL equation, we get a simple equation like V, because we consider the second polarity. Even we can consider the first polarity. If you consider second, then keep the same for the entire circuit. So V, and here the second polarity is minus IR1, and here the second polarity is minus IR2 equal to 0. This is a KVL equation for the simple circuit. And as I said, in a series circuit, means when the elements are connected in series, the voltages are different. So I can write the total voltage V equal to V1 plus V2, because the current through R1 and R2 are same. So V equal to V1 plus V2. So what is V1? V1 is I into R1, V2 is I into R2. I is common and it comes as I of R1 plus R2. V by I equal to R1 plus R2, and R1 plus R2 are the series resistance, and we can consider it as a total resistance R equivalent. So V by I equal to R equivalent, or even in some textbook it is like RS. RS or R equivalent equal to R1 plus R2. So if three resistance are connected in series, then it is R1 plus R2 plus R3. Generally we can say it as R equivalent equal to R1 plus R2 plus etc. Rn. And voltage division rule. So from this concept resistance series, we get a voltage division rule. Why that voltage division? In a series connection, voltages are different, I said. So it's like voltage, the total voltage will be divided across the elements. So here voltage division rule is applicable if the number of resistance are 2. So V1 and V2 are the voltage drop, and the total voltage is V and the total current is I. So I can write V equal to V1 plus V2, and V1 I can substitute as IR1 and V2 as IR2, and means to find what is the individual voltage drop V1 and V2, the formula is the voltage division rule. So some formula comes for V1 and to find the V2. So that we are going to find it. So V equal to I of R1 plus R2. We know what is R1 plus R2. It's a total resistance. So I equal to V divided by R1 plus R2. So consider this as a main equation. And we have the individual voltage drop V1 and V2. So V1 equal to, if you substitute I as V divided by R1 plus R2, here we get what is the voltage drop across the R1. V1 equal to V R1 by R1 plus R2. V2 equal to I is V divided by R1 plus R2. If you substitute, we will get one more formula for V2, which is V R2 divided by R1 plus R2. So this is a voltage division rule. So voltage division rule is for the elements connected in series. To find what is the individual voltage drop across the elements. So suffix comes saying V1, R1, V2, and here it is R2. Next, if the resistance are in parallel, if number of resistance are connected in parallel, then how to find the total resistance, a total voltage, a total current. So in a parallel circuit, consider the R1, R2, R3, three resistance. If the elements are connected in parallel, then the current is different across the element. Current is different across the element, but voltage drop across this parallel connections is same. So V is a total voltage and I is a total current, and this total current will be divided into I1, I2 and I3. We can say I is a total current and I1, I2, I3 as a branch current. I equal to, we can write it as I1 plus I2 plus I3, because the same I will be divided into I1, I2, I3. So I equal to I1 is V1 by R1, V2 by R2, and this is V divided by R3. I equal to V by R1. What is the I1? I1 is a current through the resistance R1. V is same. R1, R2, R3 is having the same voltage. So V by R1, V by R2, V by R3, where V is common. So 1 by R1 plus 1 by R2 plus 1 by R3. And I by V equal to this. So what is 1 by R or 1 by R equivalent? That is 1 by R1 plus 1 by R2 plus 1 by R3. So to find the total resistance, the formula is this. After taking reciprocal of this 1 by R equivalent, we'll get the total resistance. And next, current division rule. So current division rule when the resistance are in parallel, because if for the parallel connection, current will be divided. So to find what is the current through the individual element, like I1, I2, I3. Here current division rule is applicable for two elements connected in parallel. So for that we are considering R1 and R2 here in this circuit. In this circuit we are considering two resistance R1 and R2. So means I1 and I2 are the branch current. So to find what is the I1 and I2, we are using current division rule. So total current I equal to I1 plus I2, and the voltage is same across R1 and R2. So we can write it as V equal to V1 equal to V2, and V equal to, what is V1? V1 is, according to Ohm's law, it is I1 R1, I2 R2. So we can write I1 as I2 R2 divided by R1. Consider this as second equation and substitute 2 in 1. So I equal to, what is the first equation? The first term is for I1. So I1 we got it as I2 R2 divided by R1, plus in first equation we have I2. So if you take I2 as common, then R2 by R1 plus 1. I equal to I2. If you take a LCM, the R2 plus R1 divided by R1. And now we got what is the branch current I2, which is I R1 divided by R2 plus R1. And if you substitute this I2 in the first equation, then we'll get what is I1. So I1 will be I into R2 divided by R1 plus R2. So here if we see, the suffixes are different. For I2 we get R1. I1 we have to consider R2. Okay. Previously V1 R1, V2 R2, but here I2 R1 and I1 R2. So anyhow the formula will be in the handbook, but still I2 equal to the formula and I1 is a formula. So current division rule is we usually apply for the two elements which connected in parallel. For if it is 3 or 4, then we can use Ohm's law. And next KVL and KCL. KCL is nothing but the incoming current equal to outgoing current. So there are two laws, KCL and KVL, Kirchhoff's current law and Kirchhoff's voltage law. So Kirchhoff's current law, in a sense, if there are three branches, and one more thing is the KCL is applicable only for the open circuit. KVL is applicable for the closed circuit. So KCL is for the open circuit. So if you consider I1 as the current here like this, if you consider the direction of current in this way, then KCL is nothing but if there is a junction, then incoming current equal to outgoing currents. So to this junction the incoming currents are I1 and I3. So I1 plus I3 equal to outgoing current is I2. So I2, I1 plus I3 equal to I2, like that. KCL. KVL, we can apply KVL only for the closed loop. If the loop is closed, then we can apply the KVL. So we consider one numerical for the KVL. So if this is a question, sometimes what happens, they will give the current direction I1, I2, I1 minus I2, वगैरह वगैरह. So if possible, we can use that, or consider whatever the name or representation we do, and later you can convert it. So for example, if this is a question, there is one source 10 volt, and there are 5 resistance, and there is a node A and B. The question is, you have to find the current which flows from the source. Source is what? 10 volt. So what is the current flows from this source? Okay, whatever the current flows from the source, that we have to find it, and potential difference across AB. So AB. So this potential difference AB, there are two paths. To find potential difference, there are two paths. One is 2 and 6, and one more is 3 and 8. We can consider any direction. The answer comes same. So we'll discuss that. So in the question, the direction or polarity, nothing is given. So now we'll see certain steps before applying the KVL equation. So now we know for the source, the long line is for the plus and short line is for the minus. So plus and minus, and there is a 4 ohm resistor, 3, 2 and 6 and 8 ohm resistor. So how to mark the polarity for that? Okay, so consider in this given circuit there are two loops. This is loop 1 and this is a loop 2. I am considering the current through the loop 1 as I1 and current through the loop 2 as I2. Consider in this direction itself. In case in answer if you get minus, then we can write within the bracket the polarity is opposite. Okay, so I'm considering the direction of I1 and I2 like this. Okay, so two loops, so current through the two loops are I1 and I2, and this 2 ohm 3 ohm, this is a common branch for both the loops. So current through this I can consider as I1 minus I2. Okay, I1 minus I2 when I consider the first loop, and if I consider the second loop, then it is a I2 minus a I1. Okay, so so first step is mark I1 and I2, and next is the polarity. So whatever the direction, whatever the thing, you consider the first polarity as plus and second polarity as minus. Plus and minus, plus and minus. Okay, and plus and minus, plus and minus. Consider in this direction the first polarity is plus and second polarity is minus. Okay, so we'll see the KVL for loop 1 and loop 2. So this is the first loop. I'm going to write the KVL for the first loop. So here KVL, when you write KVL, you can either consider the first sign or the second sign, but it should be same for other elements too. Okay, I'm going to consider the second sign in this direction. Okay, in this direction I'm considering the second sign. So in the first loop, the second sign is plus here, and when I travel through this 2 ohm, the second polarity is minus, and here through the 3 ohm it is minus, and here through the 4 ohm it is minus. So my equation comes as 10 minus 2 into, what is that, this current which is I1 minus I2, minus 3 into I1 minus I2, minus 4 into I1 equal to 0. Why there is I1 minus I2? Because 2 ohm and 3 ohm is common for both the loops. So it is like I1 minus I2. Okay, and simplifying we get the equation, this first equation. Okay, and next KVL for the second loop. In the second loop we have a 2 ohm, 3 ohm and 6 ohm and 8 ohm. 4 resistors are there. So it is 2 and 3 ohm which is having the current I1 minus I2. Okay, I1 and I2, and 6 ohm and 8 ohm ka current is I2. Okay, so in this direction, if you consider in this direction, the second polarity here it is plus, so plus, and here the second polarity is minus, and here it is minus, and here it is plus. Okay, so according to that we write the KVL equation, and the second equation is 5I1 minus 19I2 equal to 0. In calculator, if you substitute those values by considering AX plus BY plus equal to C equation, you will get the answer. or if you want you can do the hand calculation I1 and I2. So before writing the KVL or applying the KVL, make sure to mark the direction of I1 and I2, and if there is a common branch then I1 minus I2, and then polarity according to this direction. First one is plus minus, plus minus, plus minus. Okay, and then writing the KVL equation, we'll get what is I1 and I2. Okay, and the question, what is the question? What is the current through the 10 volt source? For the 10 volt source, I have considered the current as I1. So what's the answer for I1? It is 1.30 amps. So 1.30 is the current flows from the 10 volt source. And one more question is there here, to find the potential difference between A and B. Okay, so for that I am considering the circuit here, the same circuit, A and B. So here I have considered this path. Okay, so A is connected to 3 ohm resistor. The polarity A side is plus, and next is minus, and then here it is minus, and then plus, which is connected to B. Okay, and here nothing is there, so the voltage drop is 0 here. And writing the equation. Okay, so writing the equation, either we can consider the first polarity or second polarity, answer comes same. If you consider the first polarity, then plus 3, and the current through that is I1 minus I2, and minus 8 into I2. Okay, this is by considering the first polarity. When you simplify by substituting I1 and I2, we'll get what is the potential difference, means voltage between A and B. Or if you consider the second polarity, the equation comes as, what is that, minus 3 into I1 minus I2. Second polarity across the 8 ohm is plus 8 into 0.342. The answer comes as minus 0.138. So what is the difference? Difference in polarity. So within the bracket, we can write it as a opposite in direction. Okay, if you get answer in minus, just write down within the bracket opposite in polarity. This is about the KVL. The next, power and energy. In that one sample question, a circuit consists of two parallel resistors having the resistance of 20 and 30 respectively, connected in series with the 15 ohm resistor. If the current through 15 is 3 amps, find so and so. So here sometimes what happens is the circuit will be given directly, or some problem statement will be given. According to that statement, we have to draw the circuit. So according to this question, two parallel resistors. What is the value of parallel resistor? 20 and 30, which is connected in parallel, and this parallel combination is connected with the third resistor, 15 ohm resistor. And the current through the 15 ohm resistor is given, which is 3 amps. And all together is connected to one source. And no value is given for the source, and even the value of I is not given. Only one current is given, 3 amps. It's for the 15 ohm resistor. Means here. So this 15 ohm is directly connected to the source. So we can say current through the 15 ohm and current from the supply, which is I, is same. So 3 amps is same for I. And we know data for I1 and I2. So what's the question? Current in 20 and 30, means we have to find what is the I1 and I2. Since there are two resistors, we can use current division rule. I1 and I2. And next, voltage across the whole circuit. In a sense, what is the supply? Here, this unknown. And the third one is power consumed by all resistor. What is the power through 20, and power consumed by 30, and power consumed by 15. We have to find what is P20, P30 and P15. And next is what is the total power, PT. If you add all the three powers, you will get what is total power. So we'll see how to find these things. So first one is current through 20 and 30. So we can write it as I20 and I30, or according to the current division, we can write it as I1 and I2. What is the I1 formula? I1 formula is I1 equal to I into R2 divided by R1 plus R2. The suffix is different. And I2 formula is I into R1 divided by R1 plus R2. R1 is 20, R2 is 30. And I, which is 3 amps given, substituting and finding what is I20 and I30. and current through I15 anyhow is given 3 amps. And what is the second question? Voltage across the whole circuit. So to find the total voltage, we have to simplify the circuit. So 20 and 30, the resistance are in parallel. So first you have to simplify what is 20 and 30. And the answer will be added with the third resistance 15 ohm. So 20, 30 parallel instance 20 into 30 divided by 20 plus 30 plus 15, which gives 27 ohm. Means to find the total voltage, we need what is the total current and what is the total resistance. Total current is given anyhow, which is 3 amps. Total resistance, to find total resistance, we are simplifying the circuit and we got it as 27 ohm. So now total voltage V equal to I into R. So total voltage V equal to total current into total resistance, which gives 81 volt. And next is power consumed by all resistors. So power consumed by 20, 30 and 15 ohm. So we have a general formula P equal to V into I and P equal to I squared into R, P equal to V squared by R. We can use any formulas according to the data available. So here power consumed by 20. In a sense, if you know what is the what is the current through 20, then we can use this Pi squared R. We know what is current through 20. So we can use this formula I1 squared into R. Even for P30, I1 squared into R. Even we know what is the power through 15, current through 15. So we can use what is the power by using I squared into R. So here it's like I1 squared R1, I2 squared R2 and I squared into R3. Finding the individual power, and total power is by adding all the individual powers, which gives answer 243 watt. So writing unit is very important in all the numericals here. So this is about KVL, KCL and power and energy, and even ohms and current division, voltage division rule. Thank you.